Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Introduction to Transportation Engineering and Factors Affecting Transportation. Transportation plays a major role in the development of the human civilization. For instance, one could easily observe the strong correlation between the evolution of human settlement and the proximity of transport facilities. Also, there is a strong correlation between the quality of transport facilities and standard of living, because of which society places a great expectation from transportation facilities. In other words, the solution to transportation problems must be analytically based, economically sound, socially credible, environmentally sensitive, practically acceptable and sustainable. Alternatively, the transportation solution should be safe, rapid, comfortable, convenient, economical, and eco-friendly for both men and material. Transportation system. In the last couple of decades, transportation systems analysis has emerged as a recognized profession. More and more government organizations, universities, researchers, consultants, and private industrial groups around the world are becoming truly multimodal in their orientation and are opting a systematic approach to transportation problems. Diverse characteristics. The characteristics of transportation system that makes it diverse and complex are listed below. Multimodal, covering all modes of transport, air, land, and sea for both passenger and freight. Multi-sector, encompassing the problems and viewpoints of government, private industry, and public. Multi-problem, ranging across a spectrum of issues that includes national and international policy, planning of regional system, the location and design of specific facilities, carrier management issues, regulatory, institutional and financial policies. Multi-objective, aiming at national and regional economic development, urban development, environment quality, and social quality, as well as service to users and financial and economic feasibility. Multidisciplinary, drawing on the theories and methods of engineering, economics, operations research, political science, psychology, other natural and social sciences, management and law. Role of transportation engineer. In spite of the diversity of problem types, institutional contexts, and technical perspectives, there is an underlying unity, a body of theory and set of basic principles to be utilized in every analysis of transportation systems. The core of this is the transportation system analysis approach. The focus of this is the interaction between the transportation and activity systems of region. This approach is to intervene, delicately and deliberately, in the complex fabric of society to use transport effectively in coordination with other public and private actions to achieve the goals of that society. For this, the analyst must have substantial understanding of the transportation systems and their interaction with activity systems, which requires understanding of the basic theoretical concepts and available empirical knowledge. Major disciplines of transportation. Transportation engineering can be broadly consisting of the four major parts: transportation planning, geometric design, pavement design, traffic engineering. A brief overview of the topics is given below. Transportation planning deals with the development of a comprehensive set of action plan for the design, construction, and operation of transportation facilities. Transportation planning essentially involves the development of a transport model which will accurately represent both the current as well as future transportation system. Geometric design deals with physical proportioning of other transportation facilities, in contrast with the structural design of the facilities. The topics include the cross-sectional features, horizontal alignment, vertical alignment, and intersections. Although there are several modes of travel like road, rail, air, etc., the underlying principles are common to a great extent. Therefore, emphasis will be normally given for the geometric design of roads. Pavement analysis and design. Pavement design deals with the structural design of roads, both bituminous and concrete, commonly known as flexible pavements and rigid pavements, respectively. It deals with the design of paving materials, determination of the layer thickness, and construction and maintenance procedures. The design mainly covers structural aspects, functional aspects, drainage. Structural design ensures the pavement has enough strength to withstand the impact of loads. Functional design emphasizes on the riding quality, and the drainage design protects the pavement from damage due to water infiltration. Traffic engineering. Traffic engineering covers a broad range of engineering applications with a focus on the safety of the public, the efficient use of transportation resources, and the mobility of people and goods. Traffic engineering involves a variety of engineering and management skills, including design, operation, and system optimization. In order to address the above requirement, the traffic engineer must first understand the traffic flow behavior and characteristics by extensive collection of traffic flow data and analysis. Based on this analysis, traffic flow is controlled so that the transport infrastructure is used optimally as well as with good service quality. In short, the role of traffic engineer is to protect the environment while providing mobility, to preserve scarce resources while assuring economic activity, and to assure safety and security to people and vehicles, through both acceptable practices and high-tech communications. Other important disciplines. In addition to the four major disciplines of transportation, there are several other important disciplines that are being evolved in the past few decades. Although it is difficult to categorize them into separate well-defined disciplines because of the significant overlap, it may be worth the effort to highlight the importance given by the transportation community. They can be enumerated as below. Public transportation. Public transportation or mass transportation deals with study of the transportation system that meets the travel need of several people by sharing a vehicle. Generally, this focuses on the urban travel by bus and rail transit. The major topics include characteristics of various modes, planning, management, and operations, and policies for promoting public transportation. Financial and economic analysis. Transportation facilities require large capital investments. Therefore, it is imperative that whoever invests money should get the returns. When government invests in transportation, its objective is not often monetary returns, but social benefits. The economic analysis of transportation project tries to quantify the economic benefit, which includes saving in travel time, fuel consumption, etc. This will help the planner in evaluating various projects and to optimally allocate funds. On the contrary, private sector investments require monetary profits from the projects. Financial evaluation tries to quantify the return from a project. Environmental impact assessment. The depletion of fossil fuels and the degradation of the environment has been a severe concern of the planners in the past few decades. Transportation, in spite of its benefits to the society, is a major contributor to the above concern. The environmental impact assessment attempts in quantifying the environmental impacts and tries to evolve strategies for the mitigation and reduction of the impact due to both construction and operation. The primary impacts are fuel consumption, air pollution, and noise pollution. Accident analysis and reduction. One of the silent killers of humanity is transportation. Several statistics evaluates that more people are killed due to transportation than great wars and natural disasters. This discipline of transportation looks at the causes of accidents, from the perspective of human, road, and vehicle, and formulate plans for the reduction. Intelligent transport system. With advent to computers, communication, and vehicle technology, it is possible in these days to operate transportation system much effectively with significant reduction in the adverse impacts of transportation. Intelligent transportation system offers better mobility, efficiency, and safety with the help of the state-of-the-art technology. In addition, disciplines specific to various modes are also common. This includes railway engineering, port and harbor engineering, and airport engineering. Highway planning in India. Excavations in the sites of Indus Valley, Mohenjo-Daro, and Harappan civilizations revealed the existence of planned roads in India as old as 2500 to 3500 BC. The Mauryan kings also built very good roads. Ancient books like Arthashastra, written by Kautilya, a great administrator of the Mauryan times, contained rules for regulating traffic, depths of roads for various purposes, and punishments for obstructing traffic. During the time of Mughal period, roads in India were greatly improved. Roads linking northwest and the eastern areas through Gangetic plains were built during this time. After the fall of the Mughals and at the beginning of British rule, many existing roads were improved. The construction of Grand Trunk Road connecting north and south is a major contribution of the British. However, the focus was later shifted to railways, except for feeder roads to important stations. Modern developments. The First World War period and that immediately following it found a rapid growth in motor transport. So need for better roads became a necessity. For that, the Government of India appointed a committee called Road Development Committee with Mr. J. Acker as the chairman. This committee came to be known as J. Acker Committee. J. Acker Committee. In 1927, J. Acker Committee for Indian Road Development was appointed. The major recommendations and the resulting implementations were: Committee found that the road development of the country has become beyond the capacity of local governments and suggested that central government should take the proper charge, considering it as a matter of national interest. They gave more stress on long-term planning program, for a period of 20 years, hence called 20-year plan, that is to formulate plans and implement those plans within the next 20 years. One of the recommendations was the holding of periodic road conferences to discuss about road construction and development. This paved the way for the establishment of a semi-official technical body called Indian Road Congress, IRC, in 1934. The committee suggested imposition of additional taxation on motor transport, which includes duty on motor spirit, vehicle taxation, license fees for vehicles plying for hire. This led to the introduction of a development fund called Central Road Fund in 1929. This fund was intended for road development. A dedicated research organization should be constituted to carry out research and development work. This resulted in the formation of Central Road Research Institute, CRRI, in 1950. Nagpur Road Congress 1943. The Second World War saw a rapid growth in road traffic, and this led to the deterioration in the condition of roads. To discuss about improving the condition of roads, the government convened a conference of chief engineers of provinces at Nagpur in 1943. The result of the conference is famous as the Nagpur Plan. A 20-year development program for the period, 1943 to 1963, was finalized. It was the first attempt to prepare a coordinated road development program in a planned manner. The roads were divided into 4 classes. National highways, which would pass through states, and places having national importance for strategic, administrative, and other purposes. State highways, which would be the other main roads of a state. District roads, which would take traffic from the main roads to the interior of the district according to the importance, some are considered as major district roads and the remaining as other district roads. Village roads, which would link the villages to the road system. The committee planned to construct 2 lakh km of road across the country within 20 years. They recommended the construction of star and grid pattern of roads throughout the country. One of the objective was that the road length should be increased so as to give a road density of 16 km per 100 square kilometers. Bombay Road Congress 1961. The length of roads envisaged under the Nagpur plan was achieved by the end of it, but the road system was deficient in many respects. The changed economic, industrial, and agricultural conditions in the country warranted a review of the Nagpur plan. Accordingly, a 20-year plan was drafted by the Roads Wing of Government of India, which is popularly known as the Bombay Plan. The highlights of the plan were: it was the second 20-year road plan, 1961 to 1981. The total road length targeted to construct was about 10 lakhs. Rural roads were given specific attention. Scientific methods of construction was proposed for the rural roads. The necessary technical advice to the panchayats should be given by state PWDs. They suggested that the length of the road should be increased so as to give a road density of 32 km 100 square kilometers. The construction of 1,600 kilometers of expressways was also then included in the plan. Lucknow Road Congress 1984. This plan has been prepared keeping in view the growth pattern envisaged in various fields by the turn of the century. Some of the salient features of this plan are as given below. This was the third 20-year road plan, 1981 to 2001. It is also called Lucknow Road Plan. It aimed at constructing a road length of 12 lakh kilometers by the year 1981, resulting in a road density of 82 km/100 sq.km. The plan has set the target length of NH to be completed by the end of 7th, 8th, and 9th 5-year plan periods. It aims at improving the transportation facilities in villages, towns etc. such that no part of country is farther than 50 km from NH. One of the goals contained in the plan was that expressways should be constructed on major traffic corridors to provide speedy travel. Energy conservation, environmental quality of roads and road safety measures were also given due importance in this plan. Role of transportation in society. Transportation is a non-separable part of any society. It exhibits a very close relation to the style of life, the range and location of activities and the goods and services which will be available for consumption. Advances in transportation has made possible changes in the way of living and the way in which societies are organized, and therefore have a great influence in the development of civilizations. Transportation is responsible for the development of civilizations from very old times by meeting travel requirement of people and transport requirement of goods. Such movement has changed the way people live and travel. In developed and developing nations, a large fraction of people travel daily for work, shopping, and social reasons. But transport also consumes a lot of resources like time, fuel, materials, and land. Economic role of transportation. Economics involves production, distribution, and consumption of goods and services. People depend upon the natural resources to satisfy the needs of life, but due to non-uniform surface of Earth and due to difference in local resources, there is a lot of difference in standard of living in different societies. So there is an immense requirement of transport of resources from one particular society to other. These resources can range from material things to knowledge and skills like movement of doctors and technicians to the places where there is need of them. Factors affecting transportation. The success of transportation engineering depends upon the coordination between the three primary elements, namely the vehicles, the roadways, and the road users. Their characteristics affect the performance of the transportation system, and the transportation engineer should have fairly good understanding about them. Factors are as follows. Human factors affecting transportation. Variability. Human factors affecting transportation. Road users can be defined as drivers, passengers, pedestrians, etc. who use the streets and highways. Together, they form the most complex element of the traffic system, the human element, which differentiates transportation engineering from all other engineering fields. It is said to be the most complex factor as the human performances varies from individual to individual. Thus, the transportation engineer should deal with a variety of road user characteristics. For example, a traffic signal timed to permit an average pedestrian to cross the street safely may cause a severe hazard to an elderly person. Thus, the design considerations should safely and efficiently accommodate the elderly persons, the children, the handicapped, the slow and speedy, and the good and bad drivers. Variability. The most complex problem while dealing human characteristics is its variability. The human characteristics like ability to react to a situation, vision and hearing, and other physical and psychological factors vary from person to person and depends on age, fatigue, nature of stimuli, presence of drugs, alcohol, etc. The influence of all these factors and the corresponding variability cannot be accounted when a facility is designed. So a standardized value is often used as the design value. The 85th percentile value of different characteristics is taken as a standard. It represents a characteristic that 85% of the population can meet or exceed. For example, if we say that the 85th percentile value of walking speed is about 2 meters per second, it means that 85% of people has walking speed faster than 2 meters per second. The variability is thus fixed by selecting proper 85th percentile values of the characteristics. Critical characteristics. The road user characteristics can be of two main types. Some of them are quantifiable like reaction time, visual acuity etc., while some others are less quantifiable like the psychological factors, physical strength, fatigue, and dexterity. Reaction time. The road user is subjected to a series of stimuli, both expected and unexpected. The time taken to perform an action according to the stimulus involves a series of stages like perception. Perception is the process of perceiving the sensations received through the sense organs, nerves, and brains. It is actually the recognitions that a stimulus on which a reaction is to happen exists. Intellection. Intellection involves the identification and understanding of stimuli. Emotion. This stage involves the judgment of the appropriate response to be made on the stimuli, like to stop, pass, move laterally, etc. Volition. Volition is the execution of the decision, which is the result of a physical actions of the driver. For example, if a driver approaches an intersection where the signal is red, the driver first sees the signal, perception. He recognizes that is a red/stop signal. He decides to stop and finally applies the brake, volition. This sequence is called the PIEV time or perception reaction time. But apart from the above time, the vehicle itself traveling at initial speed would require some more time to stop. That is, the vehicle traveling with initial speed u will travel for a distance, d equals vt, where t is the above said PIEV time. Again, the vehicle would travel some distance after the brake is applied. Visual acuity and driving. The perception reaction time depends greatly on the effectiveness of driver's vision in perceiving the objects and traffic control measures. The PIEV time will be decreased if the vision is clear and accurate. Visual acuity relates to the field of clearest vision. The most acute vision is within a cone of 3 to 5 degrees. Fairly clear vision within 10 to 12 degrees, and the peripheral vision will be within 120 to 180 degrees. This is important when traffic signs and signals are placed, but other factors like dynamic visual acuity, depth perception etc. should also be considered for accurate design. Glare vision and color vision are also equally important. Glare vision is greatly affected by age. Glare recovery time is the time required to recover from the effect of glare after the light source is passed, and will be higher for elderly persons. Color vision is important as it can come into picture in case of sign and signal recognition. Walking. Transportation planning and design will not be complete if the discussion is limited to drivers and vehicular passengers. The most prevalent of the road users are the pedestrians. Pedestrian traffic along footpaths, sidewalks, crosswalks, safety zones, islands, and over and underpasses should be considered. On an average, the pedestrian walking speed can be taken between 1.5 ms/sec to 2 ms/s. But the influence of physical, mental, and emotional factors need to be considered. Parking spaces and facilities like signals, bus stops, and over and underpasses are to be located and designed according to the maximum distance to which user will be willing to walk. It was seen that in small towns 90% park within 185 m of their destinations while only 66% are park so close. Indiana large city. Other characteristics. Hearing is required for detecting sounds, but lack of hearing acuity can be compensated by usage of hearing aids. Lot of experiments were carried out to test the drive vigilance, which is the ability of a drive to discern environmental signs over a prolonged period. The results showed that the drivers who did not undergo any type of fatiguing conditions performed significantly better than those who were subjected to fatiguing conditions. But the mental fatigue is more dangerous than skill fatigue. The variability of attitude of drivers with respect to age, sex, knowledge and skill in driving, etc. are also important. Two of the important constituents of transportation system are drivers and users, passengers. Understanding of certain human characteristics like perception, reaction time and visual acuity and their variability are to be considered by traffic engineer. Because of the variability in characteristics, the 85th percentile values of the human characteristics are fixed as standards for design of traffic facilities. Vehicle factors. It is important to know about the vehicle characteristics because we can design road for any vehicle but not for an indefinite one. The road should be such that it should cater to the needs of existing and anticipated vehicles. Some of the vehicle factors that affect transportation is discussed below. Design vehicles. Vehicle dimensions. Weight, axle configuration, etc. Turning radius and turning path. Visibility. Design vehicles. Highway systems accommodate a wide variety of sizes and types of vehicles, from smallest compact passenger cars to the largest double and triple tractor-trailer combinations. According to the different geometric features of highways like the lane width, lane widening on curves, minimum curb and corner radius, clearance heights, etc., some standard physical dimensions for the vehicles has been recommended. Road authorities are forced to impose limits on vehicular characteristics mainly to provide practical limits for road designers to work to see that the road space and geometry is available to normal vehicles, to implement traffic control effectively and efficiently, take care of other road users also. Taking the above points into consideration, in general, the vehicles can be grouped into motorized two-wheelers, motorized three-wheelers, passenger car, bus, single-axle trucks, multi-axle trucks, truck-trailer combinations, and slow non-motorized vehicles. Vehicle dimensions. The vehicular dimensions which can affect the road and traffic design are mainly width, height, length, rear overhang, and ground clearance. The width of vehicle affects the width of lanes, shoulders, and parking facility. The capacity of the road will also decrease if the width exceeds the design values. The height of the vehicle affects the clearance height of structures like over bridges, under bridges and electric and other service lines, and also placing of signs and signals. Another important factor is the length of the vehicle, which affects the extra width of pavement, minimum turning radius, safe overtaking distance, capacity, and the parking facility. The rear overhang control is mainly important when the vehicle takes a right-left turn from a stationary point. The ground clearance of vehicle comes into picture while designing ramps and property access, and as bottoming out on acreast can stop a vehicle from moving under its own pulling power. Weight, axle configuration, etc. The weight of the vehicle is a major consideration during the design of pavements, both flexible and rigid. The weight of the vehicle is transferred to the pavement through the axles, and so the design parameters are fixed on the basis of the number of axles. The power-to-weight ratio is a measure of the ease with which a vehicle can move. It determines the operating efficiency of vehicles on the road. The ratio is more important for heavy vehicles. The power-to-weight ratio is the major criteria which determines the length to which a positive gradient can be permitted, taking into consideration the case of heavy vehicles. Turning radius and turning path. The minimum turning radius is dependent on the design and class of the vehicle. The effective width of the vehicle is increased on a turning. This is also important at an intersection, roundabout, terminals, and parking areas. Visibility. The visibility of the driver is influenced by the vehicular dimensions. As far as forward visibility is concerned, the dimension of the vehicle and the slope and curvature of windscreens, windscreen wipers, door pillars, etc. should be such that visibility is clear even in bad weather conditions like fog, ice, and rain. It should not mask the pedestrians, cyclists, or other vehicles. During intersection maneuvers, equally important is the side and rear visibility when maneuvering, especially at intersections when the driver adjusts his speed in order to merge or cross a traffic stream. Rear vision efficiency can be achieved by properly positioning the internal or external mirrors. Acceleration characteristics. The acceleration capacity of vehicle is dependent on its mass, the resistance to motion, and available power. In general, the acceleration rates are highest at low speeds, decreases as speed increases. Heavier vehicles have lower rates of acceleration than passenger cars. The difference in acceleration rates becomes significant in mixed traffic streams. For example, heavy vehicles like trucks will delay all passengers at an intersection. Again, the gaps formed can be occupied by other smaller vehicles only if they are given the opportunity to pass. The presence of upgrades make the problem more severe. Trucks are forced to decelerate on grades because their power is not sufficient to maintain their desired speed. As trucks slow down on grades, long gaps will be formed in the traffic stream which cannot be efficiently filled by normal passing maneuvers. Braking performance. As far as highway safety is concerned, the braking performance and deceleration characteristics of vehicles are of prime importance. The time and distance taken to stop the vehicle is very important as far as the design of various traffic facilities are concerned. The factors on which the braking distance depend are the type of the road and its condition, the type and condition of tire and type of the braking system. The distance to decelerate from one speed to another is given by D equals V2U2 F plus G, where D is the braking distance, V, and U are the initial and final speed of the vehicle, F is the coefficient of forward rolling and skidding friction, and G is the grade in decimals. The main characteristics of a traffic system influenced by braking and deceleration performance are: safe stopping sight distance. The minimum stopping sight distance includes both the reaction time and the distance covered in stopping. Thus, the driver should see the obstruction in time to react to the situation and stop the vehicle. Clearance and change interval. The clearance and change intervals are again related to safe stopping distance. All vehicles at a distance further away than one stopping sight distance from the signal when the yellow is flashed is assumed to be able to stop safely. Such a vehicle which is at a distance equal or greater than the stopping sight distance will have to travel a distance equal to the stopping sight distance plus the width of the street, plus the length of the vehicle. Thus the yellow and all red times should be calculated to accommodate the safe clearance of those vehicles. Sign placement. The placement of signs again depends upon the stopping sight distance and reaction time of drivers. The driver should see the signboard from a distance at least equal to or greater than the stopping sight distance. From the examples discussed above, it is clear that the braking and reaction distance computations are very important as far as a transportation system is concerned. Stopping sight distance is a product of the characteristics of the driver, the vehicle, and the roadway. And so this can vary with drivers and vehicles. Here the concept of design vehicles gains importance as they assist in general design of traffic facilities, thereby enhancing the safety and performance of roadways. Road factors. Road surface. The type of pavement is determined by the volume and composition of traffic, the availability of materials, and available funds. Some of the factors relating to road surface, like road roughness, tire wear, tractive resistance, noise, light reflection, electrostatic properties, etc., should be given special attention in the design, construction, and maintenance of highways for their safe and economical operation. Unfortunately, it is impossible to build road surface which will provide the best possible performance for all these conditions. For heavy traffic volumes, a smooth riding surface with good all-weather anti-skid properties is desirable. The surface should be chosen to retain these qualities so that maintenance cost and interference to traffic operations are kept to a minimum. Lighting. Illumination is used to illuminate the physical features of the roadway and to aid in the driving task. A luminaire is a complete lighting device that distributes light into patterns much as a garden hose nozzle distributes water. Proper distribution of the light flux from luminaires is one of the essential factors in efficient roadway lighting. It is important that roadway lighting be planned on the basis of many traffic information such as night vehicular traffic, pedestrian volumes, and accident experience. Roughness. This is one of the main factors that an engineer should give importance during the design, construction, and maintenance of a highway system. Drivers tend to seek smoother surface when given a course. On 4-lane highways where the texture of the surface of the inner lane is rougher than that of the outside lane, passing vehicles tend to return to the outside lane after execution of the passing maneuver. Shoulders or even speed change lanes may be deliberately roughened as a means of delineation. Pavement colors. When the pavements are light-colored, for example, cement concrete pavements, there is better visibility during daytime, whereas during night dark-colored pavements like bituminous pavements provide more visibility. Contrasting pavements may be used to indicate preferential use of traffic lanes. A driver tends to follow the same pavement color having driven some distance on a light or dark surface. He expects to remain on a surface of that same color until he arrives at a major junction point. Night visibility. Since most accidents occur at night because of reduced visibility, the traffic designer must strive to improve nighttime visibility in every way he can. An important factor is the amount of light which is reflected by the road surface to the driver's eyes. Glare caused by the reflection of oncoming vehicles is negligible on a dry pavement but is an important factor when the pavement is wet. Geometric aspects. The roadway elements such as pavement slope, gradient, right-of-way etc. affect transportation in various ways. Central portion of the pavement is slightly raised and is sloped to either side so as to prevent the ponding of water on the road surface. This will deteriorate the riding quality since the pavement will be subjected to many failures like potholes etc. Minimum lane width should be provided to reduce the chances of accidents. Also, the speed of the vehicles will be reduced and time consumed to reach the destination will also be more. Right-of-way width should be properly provided. If the right-of-way width becomes less, future expansion will become difficult and the development of that area will be adversely affected. One important other road element is the gradient. It reduces the tractive effort of large vehicles. Again, the fuel consumption of the vehicles climbing a gradient is more. The other road element that cannot be avoided are curves. Near curves, chances of accidents are more. Speed of the vehicles is also affected. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.